Welcome back, Math 30-1. Today we're going to look at how odd multiplicities and even multiplicities affect a graph, okay? So we're going to start off with investigating what odd multiplicities do. Now we want to graph these three functions here, these three polynomial functions. The first thing I want to do though is find what is going to be my y-intercept for each one. Now if you remember, the y-intercept is the constant term. And the constant term is equal to, we multiply all of our constants together to get the constant term. So this is going to be 2 to the power of 3, so my y-intercept here is going to be equal to 8. The next one, we have 2 to the power of 5, so my y-intercept for this one is going to be equal to negative 32. Okay? Then I have y to the my y-intercept for this one is negative 2 to the power 7, which is going to be negative 128. All right, now let's try and graph each one. I'm going to start with the first one here. We said my y-intercept is going to be negative 8, so I'm going to plot negative 8, which is right there. And we know right here my x-intercept is going to be 2. Okay? Now if I was to graph this in my graphing calculator, we know my next part is going to be there, because these here are all actually points of inflection. Every time we do an odd multiplicity, it's going to give us a point of inflection. If we have to graph it, it's going to look something like this. Okay? Now let's try the next one, where we have negative 32. So my y-intercept is going to be negative 32. So we go all the way down, 30, 10, 20, 32 is about right there. Now this one is going to look something like this. And then we're going to have 32 up here. It's going to look something like that. Now we're going to look at my last one. This one here should have kind of gone like that a bit more. Now we're going to look at my last one, which is going to be 2 to the 7, which is 128. So my y-intercept somewhere way down over here. So I'm going to keep on going like this. And this one's going to go like that. And then like that. Okay? So I'm going to just color code these here so we can see each one and what they do. So this is my green. Okay? And then we're going to look at my yellow. Okay? So looking at that there, we learn a few things. As we increase the odd degree, we increase the speed it approaches the x-intercept. Okay? So the speed at which it approaches, so the speed at which it creeps towards my x-intercept increases as we increase my degree. Okay? I like to call these, like we found out before, I call these creepers, these points of inflections, because it creeps up or sneaks up to the intersection and then it crosses and sneaks away. Okay, then really speeds away once it's farther away. Okay, now we're going to look now at even multiplicities. Okay, so once again, first thing, if I want to graph this, I want to figure out what are my y-intercepts. So negative 2 squared is going to be 4. Negative 2 to the power of 4 is going to be positive 16. And then negative 2 to the power of 6 is going to be positive 64. So let's first do my first one, when we're going to say 4. Okay, so it's going to start here. All right. Now, another thing is these are odd. Anything that's square, we know is going to start, think of x squared, in this quadrant here and end in that quadrant there. Think of this one here. Anything to the power of 1, if I said y is equal to x, that's degree 1, we're going to end up starting in this quadrant here and end in that quadrant up there. Okay, so same idea. So if it's an odd degree, we're going crosswise. We're starting one quadrant and then we end in the opposite quadrant. Okay, just like if it was negative x, we would start in this quadrant and end in that quadrant. Okay, just like if it's negative x squared, we would start in this quadrant and end in that quadrant, as it makes a frown face, a sad face. Okay? But we're looking at, these are positives. Okay? So I look at this, we're starting up here, and we have right there. So my graph is going to look something, my my x-intercept is going to be 2. So my graph is going to look something like this here. It's going to go up and like that. Okay? Now let's take a look at my next one, where we have minus 2 of 16. So my next one is going to be at 16, which is around there. So this one's going to look something like this. And then I'm going to do that one in yellow, maybe. So you can see the difference. Okay, and then I'm going to look at my last one, which is 64, so that's going to be somewhere up here. And this one's going to look something like this. And that is my last one. So as we look at these here, these ones come in a lot faster, so they increase the speed at which they approach my x-intercept as the degree increases. So as we look at that here, when as the degree lowers, it's kind of like stretching it horizontally or compressing it vertically. We're kind of stretching it horizontally as the degree lowers, and as the degree increases, we're kind of stretching it vertically, you might say, as we're stretching these up as the degree increases, or as it decreases, we are compressing it vertically, so it comes down a bit, okay? So that's essentially what happens. So if we look at both of these, the one thing that stays the same is that for this one up here, we have a point of inflection to 0. So if all the graphs have a point of inflection at 2, 0. And for this one right here, all the graphs are tangent to the x-axis. At 2, 0. Okay? So those are the key things. So anytime we have even multiplicities, we're going to get a tangent to the x-axis, and every time we have an odd multiplicity, we're going to get a point of inflection. So my evens are touchers and my odds are sneakers. Okay, so now we're going to look at this part here. Okay, it says even and odd multiplication of 0. So basically, every time we have an even, it is going to be tangent, like we said. Even multiplicity is tangent, and odd multiplicity is a point of inflection. Those are the key things. So now we're going to look at classroom example 1. We have 4 graphs here, and we want to say what is the factors of the graph here. So we could kind of more or less guess what kind of factors there are and how many roots there are. So in each case, state the number of distinct zeros. So let's first look at graph 1. Okay, so how many distinct zeros are there in graph 1? I take a look at it. I cross once, twice, so I have 2 different zeros. So I have 2 distinct zeros. Okay, now I look at these here. This first one here is a toucher, so that means it is a point of tangency. So it's tangent to the x-axis. So we have 1 real root, or real 0, of multiplicity, in this case, it's going to be an even multiplicity. Multiplicity. And it's even, so that's going to be anywhere between 2, 4, 6, and so on. Okay? And this one here is a sneaker. So we have 1 real root, and since it's a point of inflection, it's going to be odd multiplicity. So 1 real 0 of multiplicity. It must be odd. So that could be 3, 5, or 7. Okay? Now let's take a look at number 2. Okay, so number 2, we have a crosser, which is going to be degree 1, and then we have a toucher, which is a tangent, and then we have another crosser. So for this one right here, I have 3 distinct roots. Since it touches at 3 different points my x-axis, or 3 distinct zeros. Sorry. Okay, so I look at that here. The first one's a crosser, and we have another crosser. So I have 2 roots of degree 1 or multiplicity 1. And I have 1 root or 1 zero. This should be zeros again. Of multiplicity. 2, 4, 6, dot, 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 and going on. Of 2, 4, or 6, one of those. Okay, so we just know it's even. Okay, let's take a look at number 3. Okay. So number 3 says we have a toucher, and then a crosser. So we have 2 tangents and a crosser. So altogether I have, again, 3 distinct roots. Or 3 distinct zeros. Okay? So I look at that here. I have 2 real zeros. 2 real zeros of degree, so multiplicity. And we're going to have 2, 4, or 6. And I have 1 real root, a real zero. 1 real zero of degree of multiplicity 1. Okay, now let's take a look at number 4. Here I have 1, 2, 3 distinct roots, or 3 distinct zeros. Okay, I have 1, 2 crossers. So that's 2 real zeros of degree 1. So multiplicity 1. And I have 1 real zero of multiplicity . We could have either 3, 4, 5. Not 1, because 1's just a crosser. So of multiplicity 3, 5, or 7. And it could go up, it could be maybe even 21, we're not sure. Okay? So which graph could represent a polynomial function of degree 8? So I want to know which one represents polynomial function of degree 8. That means the sum of all multiplicity, or the sum of degrees. Okay, so the sum of exponents must equal to 8. So if I have this, let's look at this first one here. We end up having here a odd, an even and an odd. So an even and an odd added together, there's no way we could get a sum of 8. So this one cannot be of degree 8. Let's look at graph 2. Here we have an odd, so 1, 2, so it's definitely 2, and then an even. So graph 2 could be of degree 8. So I'm going to put that down here. We know that graph 2 could be of degree 8. Let's check graph 3. Graph 3, it's even, even, odd. So even and an even gives me an even, but when I always add 1 to it, it's always going to be odd. So graph 3 cannot be of degree 8. Now let's take a look at graph 4. Here we have an odd, which is 1, 2. So those are only degree 1, so that's 2, plus an odd. no matter what, when I add 2 to an odd, I'm always going to end up getting an odd number. So graph 4 cannot be of degree 8 as well. Now it says, which of the leading coefficients are positive? Okay, so if I remember, x squared, so when it's even and positive, it makes kind of like a happy face. If it's negative x squared, so if it's a negative coefficient and an even, it's going to be a sad face. Okay? Now let's look at x. Y is equal to x. That gives me just a graph like that. So if it's positive, it's going to go from quadrant 3 to quadrant 1. If it's a negative, it's going to go from quadrant 2 to quadrant 4. It's going to be a decrease. So let's take a look at these. Which ones could be positive? This one here goes from quadrant 2 to quadrant 4. So this is a negative odd. So this one's not it because that's negative. Okay? Let's take a look at this one here. This is quadrant 2, quadrant 2 to quadrant 4. This is a frown face, so this is a negative even. Now let's take a look at this one here. We go from quadrant 3 to quadrant 1. Hey, that's like an incline. That's an overall incline. So this one is a positive. So now I know that graph 3 may work for this. Now let's try graph 4. We go from here to there, quadrant 3 to quadrant 1. Well, this is an incline 2 overall from where we start and where we end. So this one is also going to be a positive. Okay? So we had two graphs that worked, graph 3 and graph 4. So now let's look at example number 2. So without using a graphing calculator, it wants us to graph this function. Now here's one thing I want you to look at. We have negative, and then we're going to have x minus 0 or x plus 0. So this one here is degree 1, so I actually have a crosser at 0, and this is degree 1. I'm just going to put a 1 there so I know it's degree 1. Then at positive 1, I have a toucher or a point of tangency at 1. Okay? Then we look at this here. At 4, I have another crosser. And so I'm going to put a 1 there so I know it's a crosser. Now, this, what is my total, what is my sum, my total degree, so my sum of exponents? I have 1, 2, 4. So I have 1 plus 4 plus 1, which gives me degree 6. So I know it's even, so it's going to be kind of like a happy face with a little bubble. So I know I'm going to start, oops, and we know it's even, so it's going to be a happy face or a frown face. But now, because of the negative in front, my leading coefficient is going to be negative, so therefore I know I'm going to have a frown face. So I'm going to start down here, and I'm going to end down here. Okay? With a little bit of mumble jumble in between. So we start off here. We know this is a crosser, we said. Then we have this 4, which is going to be a toucher. And we go up to another crosser, and then down. Now we could put this in our graphing calculator and check, and it's going to give me something that looks more like this, and I think this will go up higher and then down like that. Okay, now let's look at this next question, example number 3. The following graphs represent the polynomial function of the lowest possible degree in each case. So we're going to assume lowest possible degree, and that's normally what we do. So state the degree of each polynomial function. So let's first state the degree. We look at point A here. This is the lowest this could be since it's a toucher or tangent. Point of tangency is 2. Where else does it cross? D, it just crosses, so that's going to be a 1. That's the lowest that will be. And then we look at F. It's a crosser as well, so that's going to be degree 1 or multiplicity 1. So my total degree is going to be 4. All right? Now, so 1 is done. We stated the degree of the polynomial function. Now, it says for when the polynomial function equals to 0, state the points on the graph which represents real roots and equal roots. So which ones are real and equal roots? So let's take a look at number 2. Now, I take a look at A. This is real and equal. So at point A, we have real and equal roots. There is at least 2 there. It's a multiplicity of at least 2. Could have been 4, but since it's the smallest degree, we're going to say 2. So it's 2 real roots at whatever point A is. Now, if I look at this one here, there's only one equal root. So there's no other root equal to this one here. And same with that one because they're degree 1. So my answer is only A. Okay, let's take a look at B. So first let's do I. We want to know where it crosses. We cross here at point P and we cross at point S. That's the only time it crosses or touches the x-axis. And both of these are points of inflections. These are sneakers. They kind of sneak towards it, then sneak away. So point P is going to be a minimum of 3, and point S is a minimum of 3, which gives me a total of degree 6. Okay? So now let's take a look at the second one. So we're going to do part 2 here. It says state the points on the graph that represent real roots. So here we want to know which points can have more than one. This one, we know we have at least 3 factors of the same value. So point P is one of them, and it's a real root. And point S is another one where we know we have at least 3 values of the same root. And the minimum it could be is degree 6, okay? Or 3 for each of those. All right, question number 4. It says, on the grid, sketch a graph of the polynomial function satisfying the given conditions. So first thing I want to do whenever I sketch, I want to know where I'm coming from and where I'm going. So I'm going to figure out what my degree is. So here I have a 1, and then I have 2 real roots of multiplicity 2 plus 2 plus 2. And then I have one real root of, or one real 0 of multiplicity 5, so plus 5. So I know I'm degree 10. Okay? And it is a positive leading coefficient. So it's even, positive, that's going to be kind of like a happy face, so I'm going to start up here and end here. Next thing I want to do is, we're going to state where my zeros are. So first we have multiplicity of 1. So that's right there. Then we have 2 real zeros of multiplicity 2. So it's going to be 1. And we have a 2 and a, oh, I'm going to move this over here, and another 2. And then I have 1 with 5. Okay? So let's try and make this up. So first one's a crosser. Then I'm going to have a toucher. Then I'm going to have another toucher. So I have 2 tangents. And then I have a sneaker. So it sneaks close and it sneaks away. So my graph is going to look something like that. I start there and I should finish there. And look how it works out. I start and finish where I should, so I did it right. So I came from here and I finished where I should have. Okay, now the next one says negative leading coefficient, 2 real multiplicities of 1. So that's 1 plus 1. Find my degree first. First thing I always want to do is find my degree. 1 real 0 multiplicity 3, so plus 3. And 1 real multiplicity 4, plus 4. So that gives me 5, which is going to give me a total of 9. And it's a negative leading coefficient. So that's going to be a decline, right? So I'm going to go from here and end here somewhere. Okay? So it's from 3 to there. Because if I looked at y is equal to negative x, that graph looks something like this. Okay? Now, I look at this, 2 of multiplicity 1, so I have 1, 2. And then I have 1 of multiplicity 3. Okay, so I'm going to do that there. This is a multiplicity 3. And then I have 1 of multiplicity 4. And there's my 4. Okay, so we go here, we cross, and we cross. Multiplicity 3 is a sneaker. It's going to sneak and sneak away. And then we have a toucher, and it follows our thing, and that is how we do these.